Welcome to a lesson on line integrals in R3. So hopefully you already watched the video on line integrals in R2. This is just an extension of the same idea into 3 dimensions. So if we have a continuous function f of x, y, z in a region containing a smooth space curve given by the vector valued function as we see here, where t is on the closed interval from a to b, then we can evaluate this function of 3 variables along the space curve with respects to s by evaluating this integral here with respects to t. So we first convert the function f of x, y, z into a function of t by replacing x with x of t, y with y of t, and z with z of t from the components of the space curve. And then we replace differential s with the magnitude of r prime of t dt. And as we mentioned in the last video, replacing differential s with the magnitude of r prime of t dt should be somewhat familiar to us because we did do this when we were determining arc length of a space curve earlier in the semester. Let's take a look at our first example. We want to integrate the following line integral from the point 0, 0, 0 to the point 2, 5, 4. So we first need to define r of t for this path. So if we let the x component be 2t, the y component be 5t, and the z component be 4t, this would be the path of our line integral as long as t is on the closed interval from 0 to 1. This also tells us that x prime of t would be equal to 2, y prime of t would be equal to 5, and z prime of t would be equal to 4. Let's go ahead and set this up in terms of t. Limits of integration would be from 0 to 1. Now we're going to go ahead and rewrite the given function in terms of t. So we'll have 2 times x times y, so we'll have 2 times 2t times 5t plus 3 times z, which would be 3 times 4t. I'm going to multiply this by the magnitude of r prime of t. So we're going to have the square root of 2 squared plus 5 squared plus 4 squared dt. Let's go ahead and simplify this. So we're going to have 2 times 2t times 5t. That's going to be 20t squared. This will be 12t. This will be the square root of 4 plus 25 plus 16. That's going to be the square root of 45. Let's go to the next page. Here we have a common factor of 4. Let's factor out 4 square root 45. We'll be left with 5t squared plus 3t. The square root of 45 simplifies to 3 square root 5. So we have 12 square root 5. Now we'll go ahead and integrate. We'll have 5 times t to the third over 3, or 5 thirds t cubed, plus 3 times t squared over 2, or 3 halves t squared. So when t is 1, we'll have 5 thirds plus 3 halves. When t is 0, these are both 0. Common denominator here would be 6. So we have 12 square root 5 over 1 times, this would be 19 over 6. And this simplifies here. Now we can multiply. We have 2 times 19, that's 38 square root 5 all over 1. So the result would be 38 square root 5. Let's take a look at another example. Here we want to integrate the following line integral along r of t equals cosine t sine t t, which is a helix, on the closed interval from 0 to pi. So notice in this problem they've already given us the vectored valued function for the path of integration. So here's x of t, y of t, and z of t. So we know that x prime of t would be equal to negative sine t. Y prime of t is equal to cosine t. And z prime of t would be equal to 1. So let's go ahead and convert our function to a function of t, and then replace differential s with the magnitude of r prime of t dt. We know the interval for t is from 0 to pi. We're going to have 2y times sine z. That's going to be 2 times sine t. And sine z is equal to sine t because z is equal to t. Then we're going to have the magnitude of r prime of t, so we'll have sine squared t plus cosine squared t plus 1 squared, or just 1. So let's take a look at this square root here. Well, all of this is equal to 1, so this becomes the square root of 2. Let's go ahead and factor out the square root of 2. And we'll write this as 2 sine squared t dt. And let's go ahead and finish this on the next page. Now here we'll have to apply the power reducing formula for sine squared t. Here's the formula here. Notice the 2's here simplify out. So we just have 1 minus cosine 2t dt. Then of course here we have a u substitution. So when converting to u, we'd have an extra factor of 1/2. So we'll have t minus, this will be 1/2 sine 2t Now we'll go ahead and replace t with pi and then 0. Well, when t is pi, we'll have pi minus, the sine of 2 pi is 0, minus, and then when t is 0, these are both 0 again. So we're left with square root of 2 times pi. So the result would just be the square root of 2 pi. And that's going to do it for this video. I hope you found these examples helpful.